So let's solve today's POTD, paths in matrix whose sum is divisible by k. Basically, we are given a matrix, n cross m matrix, where we have to start from 0, 0 and we need to reach the n minus 1, m minus 1 position. I have replaced n and m just for my convenience, and the only two moves which are allowed are down and right. And we need to return a number of paths where the sum of the elements on the path is divisible by k, and we have to return it modulo 1e9 plus 7. So these questions are very common DP problems. Let's look at the constraint first. So product of the rows and column is less than equals to 5 into 10 power 4, and k is 50. So basically what I can do is I can define DP state as dp I j and some mod, or let's call it k. So it means that the number of ways to reach n minus 1 comma m minus 1 from I comma j such that the sum of elements in path give me modulo k gives modulo, actually let's make it some other variable, let's call it b, gives b. So if my dp state is, let's say, 0 3 4, then it means that the number of ways such that I can reach from the number of paths such that I can reach from 0 4 to n minus 1 n minus 1, such that the sum of elements in the path when we do modulo with k will give remainder b. So let's just start the coding. These are the rows, maximum number of rows, and this is the maximum number of columns. Now let's define our dp function. I will be using a lambda function I j. Now as far as the constraint is concerned, m times n is less than equals to 5 into 10 power 4, and we are taking another state b which can go till, which will go from 0 to k minus 1 only, because we will keep doing the modulo with k. So it's 50 times 5 into 1e4, which is acceptable, which is an acceptable range. The return type will be integer, and let's define a constant, and now if I is equal to n minus 1 and j is equal to m minus 1, then we have to return whether b mod k is equal to 0 or not. If it is not 0, then if it is 0, then I will return one possible way. If it is not 0, then this path is invalid, so I will return 0. And if I is greater than equals to n, or j is greater than equals to m, then we will simply return 0, because this is not a valid path. And now comes the memoization check. If dp ijb is not equals to -1, then I will simply return dp ijb. And now I have two options, either I go down or I go up. When I'm in I comma j, I have to take this element and I have to go to some other position. Okay, actually here if I am at I comma j, then I have to take the I comma jth element, and then I have to do the remainder with the elements which already came. So sum of the vi comma j plus b, and then I will do mod k. Similarly, when I am at I comma j, I will do in new, let's call it the new one, vi j plus b modulo k. Now I can go to down. Down is f I plus 1 comma j comma new, and I can go right. New, and in the end I have to return the addition. Let's memorize it. I have to add it. So down mod plus right mod whole mod, and I think we are good to go. Return f comma f 0 comma 0. Initially the remainder is 0, and as we go we will add the current element with the previous ones, and we will do the modulo k, and we will pass it to down and right, and when we reach the end we will do the same thing, and if it is 0 we will return 1, otherwise we return 0, and okay, it's fine. And we add both ways because we need to find the total number of ways. Now declaring the dp array. Let's just make one global dp array. So first 5 25 into 1e5, 25 into 1e5 will be the, okay, let's just define one dp int dp. What is m? Okay, no, I have to know the individual m and m. Vector of int dp. Now we will have n m comma k plus 1. Okay, is also sufficient. Yes, we are good to go. Now, yeah, it's accepted. And one more thing, as far as the time and space complexity is concerned, time complexity will be bigger of the states. The I go till n into m into k, and space complexity will go till same. I am using a 3D array, n into m into k, and in question the n into m is given like individual n and m can go till 5 into 1e4, but another constraint is given that always your product of n and m will be less than equals to 5 into 1e4, so hence it got accepted. Thanks for watching.